Okay, I like that last one. See? Yeah, okay. I like that last one. Seems like I had some dates like that once. Okay, there we go.
Here we go, we're rolling. Make your introduction, Mike.
Okay, so I'd like to introduce Reggie Janes before our main speaker starts. Reggie has some things to say about some advanced work on Tesla coils.
Thanks. I'm Reggie Janes. I actually have a PhD. I do work in electrical engineering. I've been interested in Tesla for quite a while. I like to read about him, and I've been interested in Tesla coils. I originally made spark gap Tesla coils, but then I became
Close to the mic as possible.
I'm sorry, can you hear me okay? But then I became interested in making solid-state Tesla coils because there's certain things that you can do with solid-state Tesla coils that you can't do with the spark gap. Solid-state, I use FETs, high-power transistors. When you have a transistor, you can basically control the phase, the frequency, you can modulate it. When you have a spark gap Tesla coil, basically the spark gap is kind of a random process, and it will break down at random times, so you can't really control it. You can't use it as an amplifier. I've been working on trying to make a completely solid-state Tesla coil. This here is a Tesla coil. It's etched on a PC board. It's something that could be mass-produced. I also built a solid-state amplifier. It's basically a switching power supply. It's a high-performance one. It can take a signal anywhere from 0 to 3 megahertz, and you put in a 5-volt signal, and depending on the voltage you put into it, it'll handle up to 1,000 watts at a kilovolt. And I use basically when I'm using this power supply, I don't need to tune the. Usually Tesla coils, you have a primary circuit and you have a secondary circuit, and you have a capacitor. You charge it. The capacitor breaks down, and the primary circuit oscillates at a frequency, and you want that frequency to be close to the natural resonance of the secondary coil. And so you have to get that tuned up so it works. Now with this amplifier that I have, I just put a few turns around the outside, and I can tune in any frequency. It's basically broadband. This will have several different resonances, and I'll set up my signal generator, and I'll tune it to one resonance or the other resonance. Don't have to do any tuning with the capacitor or anything, just put the signal in. I mean, you could control it with a computer or whatever. The reason why I was interested in this is I was originally doing work with piezoelectric material, and it's hard to find drivers that can drive that, and I kept on building better versions of the amplifier, and I finally came up with this version, which we could provide if people are interested. I can build them specially. So now I'll start a video, and I'll show you some of the solid-state Tesla coils that I've been working on. Yeah, you wanna? Okay. These are some of the original coils that I built. I started out building a 6-inch coil, and I realized that the windings were so fine that I couldn't get a high enough Q to get sparks out of it very well. So then I went to a 8-inch coil. This is a 10-inch coil, and this is a 12-inch coil that I brought today. And basically, let's see. See if this thing. This is the primary here. I have some speaker cable that I got from Radio Shack. I turned 4 turns. They're basically 12 inches in diameter. The PC board is sitting on top of that. You can see the cables coming down here. I basically have a RG58 BNC cable that I can pipe the power across the room up to this coil. And I put a little neon light. I have a pin here coming out the center of the coil. I put a neon light up here so I can basically tune in the resonance. I don't want to run the coil at high power when I run it off resonance, or I could blow out FETs, destroy the. Basically, if I blow out a FET, I have to unsolder it, put a new FET on, put the heat sinks on. I mean, this amplifier, in order to handle a kilowatt, I got 4 CPU fans to draw the heat off of the FETs. So when the FETs get too hot, they just pop. Now, what I'm doing here is I'm turning up the power slowly. I don't like to crank it on instantaneously because if you get ring back also, you can blow your amplifier. This is 12 inches across, so you can kind of judge how big that spark is. Now, what I found is that if I want to make a big spark, this is basically I'm generating a signal from the signal generator that is about 1.3 megahertz. That's the natural frequency of this coil. That's the resonant frequency that's got the highest Q here. And then I modulate it. I have an AM modulator. I use a Tektronix 504 oscillator, and then I modulate it with an external source. And I have a very low duty cycle because I can only supply so much power to the amplifier. I could run the CW, but I get a lot longer sparks when I modulate it. So I have it turned off for a long period of time and allow the capacitor to charge up, and then it'll turn on for a short period of time, and that's the spark that you're seeing here. And I have a second signal generator that's modulating it at about 10 hertz. I can actually modulate this at any frequency that I want. I can go up to hundreds of kilohertz. Now, in order to make big sparks like this, normally a Tesla coil will kind of self-resonate and it will find its own resonant frequency. Since I'm driving this with a signal generator, I can drive it at any frequency I want. I can drive it off resonance. And what I do when I turn up the power is I have to actually detune the resonant frequency. I bring it to a lower frequency because as the spark gets bigger, the coil wants to resonate at a lower frequency. It's kind of an unusual spark. You wouldn't normally see a long dagger-like spark like that from a normal Tesla coil. This is a 40-watt neon light bulb. I can actually light that up CW too, or continuous wave. If I run it without pulsing it, I can light that thing up pretty brightly.
Where's the spark jumping to?
It's just going straight up in the air, just like a streamer from a Tesla coil, except for usually Tesla coils that kind of arc out like that. I can actually make it arc out like that if I tune the frequency up so it's more resonant, then it'll become more branchy like a normal Tesla coil. But this is operating a little bit below the resonant condition, or I should say resonant without the spark. The plasma here detunes the coil. Actually, I could probably maybe fast forward a little bit. Sorry. It's the neon, or the fluorescent light bulb. Okay, I turned down the power because when I'm doing things with the coil, if I have the power up high and you don't have it right at the right frequency, the impedance, basically the input impedance of this circuit is frequency dependent. And here, what I'm doing is I'm changing the modulation frequency. This is the second signal generator that I have, and I changed it from 8 hertz to basically about 60 hertz. And you can see that the spark has a different type of characteristic. And what I'll do now is I'll vary the frequency. As I detune it to a lower frequency, it'll become more dagger-like. And when I detune it to more resonant, it uses more power. I have a bird power meter hooked up to the BNC cable so I can see how much RF energy is going through the device. And I think this is probably about 300 watts that I'm running. Now, when I tune it up, see this is detuned, and then when I tune it up higher frequency, it'll become more branchy. The streamers will become shorter, and it uses a lot more power. It's kind of unusual. You wouldn't see something like this with a normal Tesla coil. And this sound that you're hearing, this is a sound. It's the frequency is basically the spark coming off the Tesla coil is making that. It's kind of almost like a speaker. I can tune that up to any frequency that I want or modulate it. This is probably a few kilohertz right here. There, I'm detuning it to a lower frequency so it becomes more dagger-like. Okay. Further. Okay, you can stop there, I believe. Okay, this is a real high frequency. As I modulate it to higher and higher frequency, the spark becomes smaller and smaller and more brush-like. So you see different, unusual phenomenon as you vary the parameters on the oscillators. Yep. Okay, we can probably go. Okay, that's a much higher frequency one.
Could you say your name once more?
My name's Reggie Janes. I'm from Lowell, Massachusetts. It's kind of a long flight out here.
Okay.
I think that was all I was going to show on the video. Yeah, I've been working on this for a little while. It's kind of difficult to get one of these to work. It's in order to get this to etch with this kind of resolution and a repeatable pattern. I mean, it's probably several hundred feet of wire, maybe 1,000 feet of wire, if you count it linearly around this coil. And this is the actual coil that I was using in the video. I brought it along. I had to unsolder the pin, and I wanted to bring along other stuff, but it's hard to take all that stuff on the airplane. I didn't bring the power amplifier or anything. Maybe if we have a conference out toward Massachusetts, I'll be able to set up some stuff and do some live demonstrations.
Questions?
Yeah.
Is the coil plated at the secondary?
What's that?
Is the secondary plated? It looks like you got plated.
Well, yeah. What I did is this is a RF4 fiberglass, and it's got a copper-clad board, and I etched it, and then I found out I was getting breakdown across the coils, so I put shellac on it, polyurethane actually, and that helped stop the breakdown.
Yeah,
Well, thank you.
yeah. Do you have a website or email contact info for anybody?
Yeah. I just bought a URL. It's www.newscience.us, and my email is dr_jaynes@hotmail.com.
dr_jaynes at hotmail.com.
Or you can get a hold of Bruce. Bruce will be able
And of course, Bruce is always in touch with him. And so that brings us to our main speaker for this morning. And thank you very much. We have as our first speaker a very humble man, Bruce Perrault. I had a really great interview with him yesterday and learned a lot about what he's trying to do and about the sincerity in his heart. He lives with his family in the White Mountains of New Hampshire. He's a natural scientist, and he says, "Nature was my teacher." He's been working on harnessing cosmic energy as a book. He also has a few other publications out. He's been a primary researcher into Moray's radiant energy device that was developed here in Utah many years ago. As a matter of fact, yesterday he spent some time down in Provo looking over some documents related to that. He's gone from plasma to panels like solar energy that works without the sun in a way. And he does have a website. A lot of what he's doing is channeled through that website, so it's highly recommended. I'll give you the URL right now, www.nuenergy, that's spelled NUENERGY.org. So here is Bruce Perrault.
Good morning. I'll read a little bit introduction from my book, Harnessing Cosmic Energy. This is an accumulation of my work over almost a 10-year period. This is a...
Just a moment, Bruce. Let's just adjust this here.
Okay, this book is an accumulation of my work almost 10 years now with T.H. Moray's radiant energy. I first got introduced to T.H. Moray's work through reading John Moray's book that he did on his father. And since over the years, I've gathered notes from people who work directly with Moray, and I've been able to obtain some of the Moray tubes, and at this point, I've developed a valve that it's solid state, and it doesn't use a plasma.
It's important to speak louder.
I'm having a problem with this microphone here. It's kind of feedback. I dropped it on the floor there. There we go.
If you'd like some of this put up on the overhead, I can do this.
Dr. Thomas Henry Moray of Salt Lake City, Utah, was probably the first to use radiant energy as a source of power. His tireless effort to gain recognition for his work has been an inspiration to me. The original concepts presented by the late Dr. Thomas Henry Moray of Salt Lake City from the year 1909 to 1974 have paved the road to our energy independence. He made history by drawing the attention of the scientific community to certain discoveries of far-reaching importance. His research involved the direct application of radiant energy to the ultimate electrical particles of the atoms and molecules of the universe. Dr. Moray's discoveries, when demonstrated, convinced large numbers of scientific men who had witnessed them in action. However, there were a few scientists in high places who prevented the commercial success of this technology. If these eminent men, the supposed leaders of the scientific community, had the privilege of studying under Dr. Moray, they would have understood his discoveries and applauded them. But in their ignorance of radiant energy, they refused to believe or even listen politely to the facts that often he demonstrated. One of his prototypes measured about 42 by 26 by 22 inches and weighed no more than 60 pounds. It generated around 4 kilowatts electrical power and was demonstrated in front of too many witnesses to count. Unfortunately, these few people know nothing of the truth, have done incalculable damage to Moray's discoveries over the years. In its widest form, radiant energy can be said to be the holy grail of free energy. Those who wish to study this exciting subject will do well to give serious attention to Dr. Moray's original discoveries. It should be easy to accept the fact that a device can be built to collect and convert ionized particles as it is to accept a radio that receives and converts radio broadcast waves. The only difference being is that the former is electrostatic while the latter is electromagnetic. One device transforms radio energy coming from a man-made transmitter to sound, while the other transposes electrical particles from natural transmitters into heat, light, or electrical power. Radiant energy is emitted as charged particles from all bodies at a constant rate. The mystery of it surrounding it will be unlocked. It will unlock untold amounts of energy. Under the proper conditions, it can be rendered susceptible to the most incomprehensible changes caused by the oscillations, pulsations, and surges throughout the universe. It was discovered by the Curies that all matter is possessed with radioactivity. It can be shown that radium, barium, uranium, thorium, polonium, etc., will imprint radiographs on sensitive photographic paper. If an oscillating tank circuit has the correct impedance, reactance, and inductance, it will absorb energy from an external oscillating electrical source. Energy is captured. The tank oscillations can be kept alive by establishing resonance with the external source. Therefore, energy is not drawn from the transformer that powers the tank circuit. In the case of the radiant energy receiver, it becomes possible to draw energy from cosmic energy with the aid of specially constructed plasma tubes. The implications of my findings to be described are far and wide. What will be revealed to you is a device that will release electrical power from the cosmic energy of the universe and a glorified radiant energy receiver. It is one that is designed to receive and convert the oscillations that are being generated. This device locks onto the very wheel work of nature. When properly constructed, it should last many years with very little maintenance, with no more than is required for a good radio receiver. It will be understood that radiant energy is being harnessed. It is not perpetual energy. Everything in the universe eventually returns from whence it came. What is claimed is a device that can extract energy that is contained in the atoms of matter, otherwise known as cosmic energy of the universe. My research has revealed that certain substances can be excited into generating radiant energy. A receiver has been built that will allow this energy to be collected and converted into useful electrical power. Unique ion valves have been built to achieve high efficiency in the prototypes. Demonstrations will be performed when the prototypes reach commercial value. By this I mean I have panels that are built that I'm working into a system. They're higher wattage that I'll be demonstrating today are proof of concept valves here, and I'll even take one. I'll disassemble one to show how they're made, and they're they're very simple. And I believe that the power source that they're drawing on is what's probably been identified as ZPE. For a lot of years, I rather doubt the existence of ZPE, but I come to believe that this energy is coming from the natural decay of all matter, and this is exactly what these ion valves here are converting. These ion valves, once they fully discharge into a load, they recharge themselves in about 6 hours indefinitely. I guess what I should do now is I'll show you my first crude experiments with what I now call a capture capacitor, and I guess it's widely known now as an ultra capacitor, a super capacitor. But I believe, my discovery here, very high capacity ultra capacitors can be built that outperforms what's available now. I haven't taken these to a commercial level yet, but I'll show you the crude experiment that I made the first discovery. In my laboratory, I've developed some plate formulas now that far exceed what you'll see today, but what you see today is going to be pretty amazing. Hello? Okay, what I have here is an ordinary aluminum plate. You can go to the supermarket, and when I first used my experiments, I just used aluminum foil. I don't know if you can see that. Okay. Now this here is like $20 a sheet. They're using them in fuel cells now. It's a nickel-based screen underneath this, and overlaid is a carbon-type fiber. It's very expensive, and I've developed plates now that are a lot cheaper. I use a graphite-based formula, and I dope the graphite. I've developed semiconductors that are based on graphite rather than silicon, and I don't have to have the high purity that you do with silicone with the graphite, and I've been able to develop plates that are a lot cheaper than this type of material. Once I go into production with them, they can be used in fuel cells, making a fuel cell very, very cheap to manufacture, and therefore making the fuel cell industry a lot more practical and bringing the electric car on the market. And of course, the industry doesn't know, they're not aware of what I'm doing at this point. You know, when I introduce them, I think I'm going to kind of take them by surprise. But I'd like to demonstrate the basic principle that I found that led me to these more advanced plates. Now this is ordinary shop towel that you can find in a hardware store, and I've soaked it with Windex. And I found that Windex is a semiconductor liquid. Doesn't really conduct well. It's got very high ohm resistance. But it works very well in this type of storage cell here. And use that as the separator and the conductive medium. Get that saturated. And the first charge takes a few more seconds, and it takes a little bit longer. And the next charge is once it's first conditioned, it's just about instant. I guess what I should do is Sonny here? Sonny Ward? Yeah. Does somebody know how to read a meter?
He was out before you. Would you like a hand?
I need somebody that could read a meter. Is Dr. James here?
Dr. James?
Yeah, that's the man that you introduced with test coil. There you go. Now, if anybody wants a outside, technician here to, or engineer to read the meter, it's fine with me. Oops. What I'd like you to do is just see what's on the voltage on here while we start. What I'll do is I'll drain this down a little bit, and then I'm going to go over to something else that will charge this up. You just measure the
voltage across the battery?
report what you see.
Okay.
I don't know if you can get that on the camera.
Looks like about 12.59 volts.
Okay, that's what we start with. Yeah, this will be a few minutes anyway. This is a little solar motor here that I use for this demonstration. It's just the proof of concept. No high wattages here. It's just to show how much energy you can store just in that little plate surface. Okay. One of these leads on the motor will be going to the cathode plate, which is my carbon fiber. The other lead will be going on to the anode aluminum plate. I'm not going to connect that right away because what I'm going to do is I'm going to give this a quick charge from the battery. It's a little bit longer when it's initially cold. I don't know if that's charging. Oh, that's loose. Yeah, that's a good thing I have to report. I've been dealing with a lot of radioactivity. I've been able to synthetically reproduce my own material. And at one of the conferences, somebody called it Perraultium, but I didn't call it that. But lack of a better name, it's not a new element. It's a synthesized material that I make from beryllium, not beryllium, barium, which is, I outline the process in my book, and one of my associates took it up to Canada, one of the universities, and brought the materials, and they called it a scam. They said that can't be done, but I'm doing it, and anybody ever wants to witness this, I'll show them how they start with the scratch material. It's non-radioactive. I'll do it right in front of everybody, and I'm going to have my own conference up there in New Hampshire. I was going to have it in October, but I found out that, I know it's leaf peeping season in the state of New Hampshire. That's when busloads of tourists come up and they take pictures of the leaves turning color. My wife decorates the front yard, and there's everybody out there taking pictures of the front yard. But it brings up the hotel rates, to the ceiling. And I think I'll be better prepared in June anyway. In June, I'll be able to bring up, I can't bring off any, hardly any stuff on these planes, especially today. I barely have enough to demonstrate today, but I think it would be adequate. I lost one of my baggages, and my wife is still looking for it. Hopefully we'll get it back. And I don't know if you can see this, but this looks like bombs. I'm lucky I got this through. My other stuff will look worse last year, but when I have my conference in June, you can read my book. I've obtained about 25 of the old moray tubes from Dr. William Rhodes. They were in storage for like 25 years, and I'll have all those out in display. I'll have my coils. I'll have my large plates. These plates that I now use, the best way I can describe them is they're solar panels that don't need sunlight. And I found out with my formulas, experiment with radioactivity, that I can get a lot of power from these cells. From a 3-inch cell, which I start off, a base material is graphite, we've been able to get over a half amp at 1.6 volts. And when you discharge the cell all the way down with something, about 6 hours, it fully recharges itself. And, I've tried to come to terms with exactly how that's happening. And, from my studies with the Moray notes and Lebon's notes, Moray's work was essentially based on Gustave Le Bon's work. His two titles, Evolution of Matter, Evolution of Forces. During the atomic bomb era, when they were developing weapons with uranium and such, the FBI went around to all the libraries and burned these books. And I can understand why now, because what they've done is they've developed a atomic theory that is wrong. It's incorrect. And, I believe they did it back then for national security. And it may hold true today, national security. But I believe that if the truth be known about atomic processes, that everybody could be free, and, energy, we could work, everybody could work 2 hours a day, and even 2 hours a week, and you have all this access to energy, and we can develop as human beings, without so much toil, and if there's no more need for wanting things, then we're not going to have the fighting that's going on, the wars, and all these big oil reserves. I hear that something like this is going to threaten the oil industry. I don't believe in these conspiracy theories. If there was really these conspiracies going on, I'd be dead a long time ago. I've had the state radiological department. One day I come home and see this state car sitting in my yard, and I had been running some errands. I come back, and he had been waiting in my kitchen for a couple of hours there for me, and I guess what tipped him off is I bought a vial of tritium from eBay, and this tube was glowing, and it was just a little. I brought it. I snuck it in my pocket as plane. I shouldn't say that. I didn't do it this time. This was before 9/11, and I passed around this vial that was glowing and completely harmless. Tritium is I believe it's 5.4 keV beta emitter. A thin piece of toilet paper will stop that emission. They use it in a lot of the exit signs in some of the universities. I've heard that some people are really paranoid about radioactivity. They've had the universities take out these exit signs that have tritium in it, and it's harmless stuff. But it shows that the great reserve of energy stored in that material, half-life of that tritium is about 12 and a half years. That means its decay rate is half gone in 12 and a half years, but it'll excite the phosphors inside the tube, brightly for many years, and it's too bad that the national security has programmed people into believing that all levels of radioactivity are dangerous to us, and they want to keep that because, for one thing, they don't want people ripping off the fuel rod inventories, which are very valuable. The public's been led into believe that it's nuclear waste. It's not nuclear waste. You can take those rods and reprocess all the materials out of there and use them from medical applications to, I wouldn't say, from a fuel rod, that type of material is dangerous because it emits radon gas. And that's the thing about radioactivity that's harmful. It's the radon gas that you breathe in. Cigarette smoke is why they get lung cancers, because there's radon in the tobacco. And when radon decays in 3.5 days, it turns into lead-210. That's a beta emitter, and that gets enlarged in your lungs and destroys your cells, and you get lung cancer. So you wouldn't take a nuclear rod and have it in your basement, but you could have local grids instead of central grid systems. Matter of fact, we have to go in that direction if these type of things aren't going to be developed quickly. In a few short years, a real terrorist attack could, take out a nuke plant or something. We'd be in real trouble. I don't know if you've seen when the grid went down for a few days. It was chaotic. These people, they've got these diesel backup generators, and I think they're all ready for survival and everything. But what happens when a couple gallons of diesel fuel run out, and they think they're going to go get it down the gas station there, and the pumps aren't working because there's no electricity? So I've been around natural radiation. Everything that I do, I don't see what they're doing in a nuclear reactor. They're actually splitting atoms, they're splitting U-235, and that's turned into very toxic radioisotopes that, like strontium-90 or radioisotope of calcium. If you get that into your system, it accumulates in your bones. And radium is also very similar to calcium. That will settle into your bones. That's what was happening with the radium girls back in the 1920s. They were licking the paintbrush and ingesting that stuff. So, that was getting into their bones. Well, like anything else, it had, certain respect. If you don't ingest that, you could make a nice power supply out of the radium. Alfred Hubbard did it. He invested in a uranium company up in someplace up in Canada, and he was coating his coils with this radium paint back then. He was getting hundreds of watts of power continuously out of this. But right now, people are too afraid of everybody's afraid of radiation, and I'm a living testament that if you don't split the atoms, because when you split the atoms, you end up with these neutrons, which, in a nuclear reactor, they're using it, they're changing its course, and they're recreating, they're manipulating the atoms in a very dangerous way by splitting them up. And those neutrons can cause a lot of trouble. That fear is justified. Matter of fact, these nuclear reactors are even more dangerous than anybody realizes, because these fuel rods are under such high pressure. This radon gas is coming out of everywhere, and what it's doing is not going all over the plant. It's slowly seeping out, going into the ground, and that radon is going to the groundwater. And this is why people in these areas of nuclear plants, they're dying. I'm in doctor's office. There's piles of folders of people dying of different cancers, and in these areas. And what's happened is the radon gets in the water table, turns to lead-210, which is now a heavy metal, and that lead-210 now reacts and forms some kind of a compound, lead oxides, whatnot. That gets into the drinking waters. People ingest it into their bodies, and that's causing a lot of trouble. However, if you don't split the atoms and you just let nature run its course, it's not dangerous. Like I said, I'm living proof of that. 14 years ago, my wife had a tubal ligation, and that's so you don't have any more babies. And my whole family's been around it. And I know there's people on the internet that hate what I'm doing, and they said that my kids should be taken away. They're in an unsafe environment. If I thought it was unsafe, they wouldn't be exposed to it. But anyways, my wife, got pregnant, and we were really shocked by it. But I'm living proof that it didn't sterilize me. And we asked the doctor when he's doing a final operation, so we couldn't have any more kids. I asked him to look at what happened to these tubes, and both sides completely came back together and healed themselves. So I've seen studies that back this up, that the natural levels of radiation actually acts as a radiohomesis, they call it. And that's a low-level assault. It's a little bit higher level of the background radiation that triggers the immune system to, go through a healing process. And it doesn't trigger it fast enough where it's unhealthy. But case studies have shown that in the like the Colorado Plateau area, there's a much lower incidences of carcinomas than in the populations that aren't in these areas. Like I said, like anything else, you don't want to go into a heavy laden mine that there's all kinds of radon gas sitting on there. That's why radioactive materials is harmful. Is that radon gas, when you breathe it in, and radium or anything like that, you get into the body. That's where it's justifiably dangerous. But because my research has been running into blocks, because I do use radiation, and so I've been forcing myself to go in a direction where I don't need to use the radiation. and I've most certainly discovered the construction methods that will give acceptable power levels. I won't be able to put out a unit that puts out 50,000 watts for a small bread box like T.H. Morey did. T.H. Morey had radium in his tubes. That's why he was able to get the high wattages. But even with that radium inside the tubes is not the source of energy. It's actually a catalyst that speeds up the reaction in the tube so that you can get that higher, those outputs. But that's why the tubes eventually wore down and he had to replace them after a certain amount of time, because it just greatly accelerated the natural. There's unstable radioisotopes in all matter, plastic, metal, everything. And everything's undergoing a natural decay process, but the half-life is over billions of years, which we don't, we don't have, the equipment doesn't measure it as, any kind of levels of radiation. And I know there are more sensitive equipment that will do it. But that's what the source of energy is. It's, when Morey made the statement that he was harnessing cosmic energy, that was based on the language of Gustave Le Bon. And the term cosmic energy is referring to matter being both energy and a solid at the same time. In other words, energy is matter in a condensed state. When matter becomes uncondensed, it turns into pure energy. And everything's naturally doing that, but in our lifetimes we don't see it because it's cycling over billions of years. And it's my feeling at this point is that's what people are calling ZPE. And why I've seriously doubted ZPE is because, I'm a nuts and bolts guy, and I have to know where this is coming from. Nobody can seem to tell me where this is coming from. All these mathematical equations to justify it, but I've got to see it on a meter, and I've got to identify the source. And it's my feeling at this point is the source of this ZPE energy that people are looking for is coming from all matter that's breaking down into pure energy. And these valves that I've, and these formulas I've designed to put out high powers with radioactivity, I discovered that I don't need the radioactivity for them to put out the power. All the radioactivity does is it's a catalyst, and it speeds up the natural decay of all matter. And I found that out one day using one of the Morey tubes, and I fired it up, and all metal in my workshop became highly radioactive. And she says, geez, I says, what's going to happen here? I'm going to have the state back in and taking their meters in, and my whole area everything's contaminated. I got really panicky because they probably bulldozed the house. But about a month later, there was no signs of radioactivity, and I don't really understand exactly why it came and went. I guess, when I speeded up the natural decay process of ordinary metal, that there was a certain half-life cycle of it was probably, 10 days or so, or something like that. But, there's some people that I've talked to up here in Salt Lake. It's great I've been able to get up here because, these people confirmed what I'm seeing, and I can't wait to talk to them and ask them why this is happening. But, he confirmed this is exactly what one of the tubes do. Does that, and he's going to be able to tell me why. Anyway, let's get back to this. I got off track here, but I guess I'm still on the main topic. But this still relates to how how I'm converting. I guess you want to call it ZPE energy. It's fine with me, but the only thing I don't like about it is it's kind of leads you off track with all the mathematical stuff, and I like to explain things and where the ordinary person who's not doing this type of research can understand it. Morey called it radiant energy. I believe Mr. Wilhelm Reich called it orgone energy, and I've just come across tubes now that from normal biological material, I can measure the decay process given off from bion materials. Reich called it, but essentially is when these biological things in the soil are doing their thing, they're giving off radiation, and but it's so minute that nothing's been developed to pick it up. And but I found these tubes on eBay that came from Edison's laboratory, and they were prototypes at the time to develop a radiation detector. The problem is with not detecting these fields is the tubes that are made today, vacuum tubes, aren't in that window, that small window wavelength that Morey probably called radiant energy, and Reich identified it as orgone energy, and there's no semiconductors that do that, but these tubes that are prototypes fall within that window. And you know, I'm going to go back out to some of the mines the rest of the summer and use this detection equipment to do more research of this small window. So whatever you want to call it, it's fine. It's real, and it can be converted into useful electrical energy. And like I said, you add some radioactive material and it speeds up the process and get kilowatts of energy out. But what I'm going to do is I'm going to introduce the first one as a proof of concept, you know, sell them for about $50, and people can experiment with themselves. And what I probably should do is, get to the first thing here. I thought he had 90 minutes. Man. No. I was saying I have 10 minutes here. I really didn't want to, I wanted to do more of demonstrations and talking. So, oops. Yeah, burnt. There's some battery leak. Okay, where's the other lead? Okay, what I did is I charged those two plates. Oh, what's happening here? That's because I'm being rushed. Let's see if I can get this one going. Some of my items here were damaged on a plane. The valves are all leaking now. They're not properly sealed prototypes. Can you pass that around to show people? I got a feeling I'm not going to be able to do what I need to do here. Yep. Okay, this has got to be soaked. I gotta get the other one working. Yeah, maybe the other one died. There's no battery attached to that. What's that? That's 2 volts that's being stored in there. Okay. I'm charging the plates here with the battery. it's my version of a supercapacitor, and I'm able to get enormous storage using my plate formula. It's a basic graphite that I oh, that's not tight enough. You know, in my plates, they're very close together and tight, and you know, because when they're apart, it's too much electrical resistance. So this demonstrates cruelly the basic principle I discovered with the capture capacitors. You know, I was doping the in between the material with radioactive material, and then you don't have to charge it. But like I said, I was running into blocks, and I'm not going to get a product out that has radioactivity, so you know, I find it acceptable to. I know I'm running out of time. How much time do I have left? How much time do I have left?
Say it again.
How much time? Damn. I was going to show you a small stack of these. We'll recharge that, but it doesn't look like I'm having much time here. Yeah, okay. Can you pass this around? You can take this out of the, well, take this tube. And this is the plate material. I can dope it with different substances, and I can make a fuel cell, or I can make a radiation cell. It'll put out a lot of power. Or I can just put ordinary salt water in there, and I can get 1.6 volts. It's really strange, though, because I can make several of these and the same exact way, and some will come out with 1.3 volts, and others will come up to almost 2 volts. And even the amperage it's putting out varies. It can vary from 10 milliamps to about a half amp. And I have no idea why, and what I'll probably do is just keep the higher ones and, you know, junk the rest of them. I think that'd probably be better than selling different types of grades. But this is just a proof of concept. You know, now this material, you'll see this, I'm plating this onto plates, and the graphite is very cheap for me, and the impurities are nothing exotic, and, you know, that's going to be a trade secret, because I'm not going for a patent. I'm just going to put these out on my website, and once people see how they work at distributors and do networking that way, I'm not going to do any public advertisement. I just think the products are going to speak for themselves, and it's, you know, you're going to be able to replace solar panels, and you're not going to need sunlight. It's not going to put out kilowatts, but it's going to be better and cheaper than solar panels still. And they keep on, after you drain them, they recharge themselves. You know, these were taking about 6 hours before they fully came back up to charge after draining one of these solar motors. You know, pass it around. You can pass the pens around at the same time. I have pens with my address and my website address on there. Pass this around too. This is. Did you pass that around? How about the alloy? I also have a special alloy. I want to take one of these apart and show you that the alloy forms a black oxide coating on it, and even though I get power out, it doesn't decay the alloy, and it took me a long time to send formulas to companies and have them make different alloys, and you know, I can get over 2 volts with using magnesium, but that stuff's eaten right up. With this stuff, it's very close to what was called chemalloy. But the difference in the formula, it doesn't have lead in there, and it forms an oxide layer that protects it from, you know, any kind of corrosion. And the electrolyte that I use in here is salt-based. It's very similar to the salinity in your blood. It's very similar to your blood without the, you know, the iron and the other stuff in it. So, you know, if you listen to nature, you can produce energy, and very naturally. So I guess I'm out of time here, and you know, I'd like to take questions and answers, but you know, I'm out of time, and you can talk to me at my booth, and I've got a lot of stuff on the website, and I'll be coming out with proof of concept products at very reasonably priced, and once I know I get a good reaction from proof of concepts, and then I'll go on to the higher wattage stuff, which I'll be demonstrating next June in Manchester, New Hampshire, and I'll post the time on that. We'll have a number of other speakers that are doing other things in other fields that are just as exciting.
Bruce, thank you very much. I don't think we have enough time to pass around your articles there, but can we make those available at your booth?
What's that?
So that if individuals want to inspect them at the break, that they can?
What-
Can we do that?
what-
If the items that you wanted to pass around,
Sure.
can we have that available at your booth? Because
Sure.
we're almost at break time now.
Okay,
Thank you very much,
great,
sir.
thank you.